So I'll be showing how I created a snake in Java. First of all, let's run the program so we see how it looks like. First of all, we see a terminal window. We can select the game speed. Let's try medium, and a new window pops up, and we can see the snake moving around. I control the snake by using the WASD keys, and it goes on and on until I crash eventually. Then the window disappears and our overall score is displayed on the terminal. So now let's take a look at the code. Because I was having performance issues in BlueJ, I decided to show this off in NetBeans. First of all, we can see a bunch of imported objects. So action event and action listener right at the beginning, these allow us to complete a certain action every time our timer ticks. And we can see the timer right here. It's javax.swing.timer. It's not the java.util.timer. That's because this type of timer is the best to use for animations, which we will use in this program. Next, the JFrame. That's the window that appeared in which we played the game. Color enables us to, color stuff like backgrounds and graphics. JPanel is the place that the graphics are drawn on the JFrame, and which brings us to the graphics section, which enables us to draw shapes and lines and stuff like that. Next, the key listener and key event. These two enable us to take inputs from the keyboard, and based on what we are pressing, what keys we are pressing, it does some kind of action. Next, the scanner. It scans what we typed into the terminal window, and based on that, it can do some actions. And the random function, we use this to randomly place the food in the game, and this is the best way to use the random function in Java. Next, the class itself. We can see it extends JPanel and implements action listener. So it extends JPanel so we can use some graphics in it, and implements action listener so we can use the action listener to do some actions every time the timer ticks. Now we add two different objects here, the timer and the action listener. We'll see what we'll do with that later. Next, we declare a bunch of variables. Most of these are common data types, but two of them, byte and this integer array, are different. That's because the byte data type is a number, but a number that fits into 1 byte of data space, which means from -127 to 128. The integer array is an array of integers. We can see that there are lots and lots of integers here, and how we can access these integers. For example, we want to access this 0 right here. Well, we do that by coordinates. First of all, we find in which array it is. It's in the second one, in this one. But because the counting starts from 0, the coordinate for this array is 1. And if we want the third 0, it will be 2 for the second coordinate, because again we start counting for 0. 0, 1, 2. There we got it. The coordinate will be 1 and 2. So what we would type is we would type the name of the variable and then in brackets the coordinates 1 and 2. That now we found this 0 right here. Now why do I use this integer array? Because this enables me to have kind of a playing field. Now I use this as a 10 by 10 playing field. Every single integer here has its function in game. We can see that by default some of the integers are changed. They're not just zeros. 2, that's food on the playing field. 3 and 4, those are the snake body, and 1 is the head. Now we'll see how that works later on. Now we see our timer set up. If the variable speed chosen is true, which is by default false, then the timer is started with the interval of the variable speed and with an initial delay of 2000 milliseconds. Because the variable speed chosen is by default false, we'll have to see when the timer actually gets started. Okay, so after we set up the timer, we have public void paint component, and we can see graphics G here. That means we implement graphics in the public void paint component, so we can use graphics in here. Now you'll see super.paint component. In this case, this enables us to repaint the graphics from the beginning every time the public void paint component is triggered. So in this public void paint component, we have our movement. If variable food eaten is false, then we keep track of the last block of the snake and we delete it, so the snake doesn't grow all the time, only when it eats food. Later on we can see this random function. This is used if the food was eaten last tick. So we can see RA, like random coordinate 1, RB, random coordinate 2, is random function from range 0 to 9, plus 1 because it isn't inclusive. So we want it to be 0 and 9 inclusive. So we add the 1 and we got it. If the space, however, is taken by the snake, we just try again until we succeed and the food is placed. Next, we have the movement of the head. We see if a direction is pressed and the direction in which the snake is looking is just not available for the snake. That means if the snake is looking out of the playfield and wants to go there, we print out game over and the score, and we exit. We end the program. But if the snake doesn't crash into a wall, the head is moved in the direction it's looking. So we can see here, if direction is W, which means it is looking upwards, and the place above the snake's head is either an empty space or food, then the snake moves in the direction it's looking in. And if the snake had replaced the food, then the variable food eaten turns into true. So the next tick, the tail, the last piece of the tail isn't removed. This goes on and on for every direction, and if the program fails to do any of these, then it means that the snake crashes into itself, and the game is over. The system exits, the program is ended, and we get our score. Next, the graphics. So, first of all, we do kind of a border around the playing field by 2 rectangles with the width of 1 pixel. So that makes a rectangle 2 pixels wide with black color. Now the program analyzes every single number of the integer array. We see if these coordinates are equals number 1, which would be the snake head, then we fill the rectangle with green. If the coordinates happen to be 2, then we fill them with red, because that would be the food. If it's 3 or greater, it would be the snake body, and we fill it with blue. Then we change the coordinates, and this goes on and on until we've searched all the coordinates, and we can make sure that we didn't leave anything out. Now the public void paint component ends, and we have public void action performed. Here is when the action listener and action event take place. Well, all that this does is repaint, which triggers the void paint component. The reason why I didn't put all the code in here is because the void action performed doesn't take graphics as an input. So instead, I repaint all of the graphics, and it works just fine. Finally, the public static void main. First of all, we add a new scanner which reads from system.in, which is the terminal window. Next, we got some text here. We print out select game speed, and we wait for some inputs. If the input is 1, the speed is 500, easy. If the input is 2, the speed is 200 in milliseconds. If it is 3, the speed is 120, which is the hardest. And speed chosen is true. Remember, at the timer setup, at the timer setup, the timer would only start if the variable speed chosen was true. So now we have chosen the speed, so the timer can start. Next, we set up the JFrame. The JFrame is the window that we play the snake in. We name it Greg's Amazing Snake Game. We have two variables here, width and height, which we use for the size of the J-frame. We'll see that in a while. Now, here are the characteristics of the J-frame. First of all, if we set the J-frame to close and the system to exit if the J-frame is closed. So if we close the J-frame, the program stops. Next, we set the size of the J-frame, which is 710 pixels and 750 pixels, which is roughly 700 by 700. Next, we set the frame to be visible, and we don't allow the frame to be resizable. Then, frame.getContentPane, add new. By doing this, we fill the frame, kind of, so we can work with it. Next, the key listener. This is where we put the inputs from our keyboard during the game. So first we need to add the key listener. Then, in a public void key typed, we test for a key, which key is pressed. If we press W, then we change the direction the snakehead is looking to up. If it's A, we change it to right. If it's S, we change it to down. And if it's D, we change it to right. And that's all there is to the program. Yeah. Summed up, we import a bunch of things. We declare the variables we need. We set up the timer. We do the movement of the snake first. We remove the tail. Then we test if the snake crashes or not. If no, we move the head. And then we draw the graphics where they're supposed to be, so we can see what we are actually playing. And then we just repaint it every time the timer ticks. That's all there is to it. Thanks for your attention.